Hello everyone, I'm going to explain on this video how to calculate the ventilation, hourly loads, and then the monthly loads for ventilation and the solar heat gains. The ventilation, but the rest of the formulas, we know that we have the UA value, the thermal transmittance times the area of windows, roofs, walls, whatever, times indoor temperature and the outdoor temperature. And the thing is now the outdoor temperature is changing hourly. So that's why we have to calculate all these values hourly. We take the values from the tabs in which we have calculated the UA. Okay, that's the thermal transmittance, that's the area, and this is the value that we get from different orientations. When it comes to the ventilation, we don't have that. We don't have the UA value. But we have something, we have a thermal load that after calculating the latent heat, the sensible heat, the heat recovery efficiency, we came up with this value. But this value depends on indoor temperature, outdoor temperature, indoor wet bulb temperature, outdoor wet bulb. So we have to do something weird here. So I'm going to calculate the thermal loads or the value ventilation values that we are going to use for the hourly calculations. Well, it's very simple. We only have to divide this by indoor minus outdoor temperature, and then we have to substitute the outdoor temperature by the hourly outdoor temperature that we have in this hourly thermal loads. Okay, let me do it. So this formula is very simple. It's just equals this value after the heat recovery divided by parentheses indoor minus outdoor. Okay, and I'm going to format this with only two decimal places, and this is the value that I'm going to use in this sheet. So in this ventilation load, that equals, I have to go back to the ventilation tab, this times indoor temperature minus, and the outdoor temperature is that one. And I have to type $ for every single value that doesn't change. And when I drag it down, the hourly thermal loads change, but this thermal ventilation value that we used and the indoor temperature, they don't change. So let's do this, and now we click and we can go down. As always, I forgot to multiply by the schedule. Schedule. Okay, so when the building is closed, we don't have any thermal loads. When the building is open, we start counting the thermal loads that we get, the BTUs that we are spending. Okay, so now that we have this column with values, and if we have the same order here, we have walls, roof, basement, windows, and ventilation, walls, roof, basement, windows, and ventilation. Now I can just select all this column. We drag this here, and these values are referring to the same column here, ventilation and ventilation. So this is the sum if I add up all the values that are greater than 0 In January, all the values are greater than 0. In July, we have values for cooling and for heating and cooling. And cooling, it's values lower than 0. Okay. So this is what I would do to calculate the ventilation loads. What about the solar heat gains? Well, solar heat gains, I have to go to the windows, because in this table of windows, we have the months. This is the value that comes from PV watts. And now I only have to change or either the solar heat gain coefficient or the area of different windows. And well, that's the value that we need there. And after that, I have to add up all the values that I have in different windows in January, and then in February and March, so on and so forth. Okay, so let's do it. First, I have to activate PV watts, because I have to do this for each city or each location. And I have to do this 4 times for the south orientation. I have to change this column. Okay, so it's important that we know that this column from PV watts, it has to be changed. When we change those values, then the rest of the things, the rest of the values here will change accordingly. So let's do it. This is PV watts. I select Keene, New Hampshire, go, we're in Keene, New Hampshire, then we go to the system. And so far we are dealing just with these. We're not dealing with PV parameters, only the window or parameter. So the tilt, if we are working with vertical windows, that would be 90. 180 means that we are in the south elevation. So let's go here, and we can download the monthly values for Keene on a vertical window on the south elevation. And I just have to copy the monthly values on this. So I have copied these monthly values, and all this has changed accordingly. Okay, look at this, I copy it again, and all these values change because the solar irradiance or radiation, this is not irradiance because this is energy per square meter. Then I turn this into these units, BTU per square feet. I multiply by the solar heat gain coefficient, and I multiply by the area of the south orientation windows. Okay, now I have to do the same with the west, east, and north. So let's do it. If I want to change, I don't change the tilt, it's always vertical, 90. But if the next one is west, I have to type into the cell 270. 70, go to the results, download the monthly results. Okay, these are the values of the western windows. Control C. Now we have the west orientation. Control V. Now I have to do the same with the east. PV watts. If this is 270, the east would be 90. The azimuth. Go to the PV watts. Download. Select the daily average values and paste it on the east orientation. And finally, I have to do the same with the north. PV watts, north is 0. The azimuth is 0. I go to the result again, download monthly data, copy and paste it in this column with the north orientation. So now everything is working well. And now the final step is that we have to calculate all the northern values that I have in my building, or all the daily energy values that we have in my building. So I have to add up the January values that we have in the north, south, west, east, and north. So I'm going to create here an all window, and that will be January. It will be February, March, and I'm doing this every other column because this is what that's the structure that I have in the other. Yep, that's the structure. I want one something decimals because this is not a number. This is just January. So that's the structure that I have. Every other row, I have a value. The same thing here because I'm going to start inserting this in the cooling loads. Okay, and I want this value to be negative. Think about heating losses and heat gains inside the building. In January, we are losing heat through the walls, but we are gaining heat through the windows. So that's why I'm inserting this in the cooling row, and it will be a negative value. So to do the same thing, I have to go to Windows, and I will add up all these values here. That will be -1 times, and then in this parentheses, I have to type this value plus this plus this and plus this one. Okay. And now I have to do the same with February. Just going to copy the same formula here. And well, that's the problem, that now I have to change this. So it's not 8, it's 9. It's not 24, it's 25. And that would be 41. And finally 57, 41 and 57. So now if I click here, I have all the values that I need in February. The next one, I copy the formula, and it's not 9, it's, yeah, I have to add 1 value more. 42, 1 unit. 48. And now this is March. If you think it's easier, we can insert here the formula of April. Will be this plus April plus April plus April. Okay. whatever is easier for you. Okay. If we are, by the way, this is 4, Chesapeake May, 5, 6, 7, 8, 9, 10. Okay, in May, I can drag this and I can use the month number 5. I'm doing it in different ways to show you that we can do the same thing in different ways. Number 5. Okay, it's good that you check that we are working with May, 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 May. So I think the easiest way is to add 1 unit here when we copy the previous formula. 29, 45, and 61. It's June. Yeah, this is June. July 14, 13, 36, 62, 15, 31, 47, 63, 16, 32, 48, 64, and 17. And finally, the last one. In December, I'm going to be selecting the cells. Okay. So now when we have all these values, I can go to the thermal loads, and on the solar gains, I only have to type equals. I go to the tab, I select the right value, and this is the right value here. And if I drag it down, I have all these values in the right cell, the right row, in the cooling row. Okay, good. And now this is all the information we need. This is usually what our clients are demanding, the heating and cooling loads, the monthly heating and cooling loads. And we have done it on a daily basis and on an hourly basis. Selecting the schedule of the building is important because I'm not consuming any energy when the building is closed. Okay, so I start consuming energy when the building is open. So I think now this is accurate enough, and I'm going to create a graphic. So I select all the values, I go to insert, I select the graphic, this 2D column, it's good, but I want the stacked column option. And this is what I get. Okay. I have different values. It depends on the area, the number of people that I have selected in the case that I run in class. I remember that the Windows solar heat gains were much more than the rest of the, but well, maybe I hear the areas of Windows, the number of people, probably it's different. So that's why I can get different value. In this case, we are farther from a zero energy building than we were in the building that I tested in class. But anyway, now it's a question of making this graphic more appealing, and we can do that by making the fonts larger. We only have to select this and increase the font. This menu, it's bothering me because it's invading that space. So if I double click in this menu and I go to labels, the label position is not next to the axis. The axis is 0. Makes sense. It has to be low. Okay, so now I can see all the values that are lower than that. And what else can I do? I can create, well, because this is clear, I have January heating, January cooling. This is a legend, so I have different colors here, so I can understand that the walls, it's this dark blue, the ventilation is this light blue. It should be, okay, if I select the colors in fill, if I can make, yep, so you see that now it's more different and I can understand the difference between the walls and the ventilation. Okay, so I think selecting the right colors, it's good. And for this, if this is the heat that we gain from Windows, I think we can make it something more related to heat, or something reddish or something like that. It's clear that this is the heat source. Anyway, and I can include the legend here. And the legend, because this is BTUs, the vertical axis. So if you select the chart, you can go to chart design and we can add elements to the chart. So I'm going to use the primary vertical axis title. And this is energy. And the units are important, BTU. Font is too small. I can make it bigger. And I can change the chart title. That would be monthly thermal loads. And we can type here the name of the building. Okay. The good thing is that now whatever you change, if you want to change the ventilation loads, if we don't have 20 people, we have only 5 and 4 people on the first floor. If you go to the chart, it changes. Okay, so it has changed. I'm going to do it more radically. So I'm going to type 0 people and 0 people here. So we only have 4 people on the second floor. If we go to this, this value has been reduced a lot. If we, instead of working with this, we work with a heat recovery of 80%. Now the ventilation value changes. If I increase the area of the windows, so I have 500. If I type 1,000, now the window energy gains, it will be much higher. Okay, so as I told you, it depends on what parameters you use, but by changing one of the parameters, it can be one of the building materials, or it can be the thickness of the material, or it can be the number of people that you have here. You can clearly see how this change affects the thermal performance of the building.